Okay, so I will now jump onto the fire side of things. How are we doing for time? So, okay, so I guess for the next 5 minutes, I'm just going to run through the main considerations around fire and solar PV on flat roofs. Now, this is a bit of a moving target. I would say it's a bit of a conversation. So we were really happy to come and talk to you guys today, because actually, particularly within Ireland at the moment, that there is I would say, grey area around what the requirements are and what we need to provide for installing solar, not just on green roofs at all, but on flat roofs particularly. And what are the impacts of installing solar on flat roofs? So I'm going to just run through a couple of minutes, a few quick slides, and then hopefully we can open up the sort of floor for a bit of conversation around this topic, because I guess what I'm about to sort of go through will probably just give you more questions than answers, but they are questions that need to be had at the moment. So to start with, solar PV on buildings is very low risk. The BRE National Solar Centre did a report, it's old now, 2018, where they analysed the incidence of recorded fires of solar PV on buildings in the UK, and they actually found that well, firstly, it was very low risk. There were less incidences per installed unit of fires from solar PV caused by solar systems than there were by tumble dryers. The main risk areas were actually where there were fires that were caused. It was largely DC isolators not being maintained or poorly installed. And then following that, so 60+% in total of the failures were due to either badly installed DC isolators or badly installed connectors. And so that is a risk area, obviously. On flat roofs, specifically, it's more the passive impact of the solar on the roof that causes the risk than the solar PV system in of itself. Now, we have a bit of an issue because under BRoof T4, which is our sort of standard for fire on roofs, it's not possible currently to test a system with a solar PV panel on top. The methodology for testing to BRoof T4 in flat roofs, we can't physically fit a solar panel on top of the roof system in the rigs that we need to test it. And so that's really limiting at the moment, because we can't physically evidence that what the impact of a solar PV system on the roof will be. The main impact that we know is not necessarily an increase in the penetration. So Bauder have been involved in some work, not building regs work, but with PU Europe and the Insulation Manufacturers Association, where we've evidenced that it's the spread of flame that's the impact. So does that solar PV system going on that roof increase the spread of flame? Well, yes, potentially. And so that's the area that we're really looking at, and that's the area of risk. So from a Bauder perspective, I would say that currently the best advice generally that we can give is that a roof should have BRoof T4 if you're installing a solar PV system on it. And then it's the design side. So ensuring that you're not locating solar panels close to any roof furniture, upstands, roof lights, penetrations, where actually the roof could, where that spread of flame could then get into the building. Within Ireland at the moment, we very much have a criteria where most of the time we are being asked to design a system to meet the Dublin Fire Brigade requirements. And so I'm not going to expect you all to read this. You're probably all aware of this guidance. I'm sure you are. But I'm just going to highlight the individual points and just run through them one by one. So RC62 guidance to start with. hopefully I'm not going to get shot down too much, or it's not too contentious. The previous or the current iteration of the RC62 guidance has, and not necessarily from a fire perspective, but from a general solar installation perspective on roofs, is problematic, and generally we don't see it referred to very often these days. There is a new RC62 which we have been working on, which will be, if we can agree the wording, will be released this year. We sent our comments back on it last week, so it's been a long time coming, but that should come through soon. But most of the stuff within the RC62 we can work to. We've then got NFPA and the MCS guide. All of that stuff is pretty straightforward, and every single system that we would design and most contractors would design will certainly be to the MCS guidance and ECA. We then get to the point where actually this is the area where we get a little bit unstuck, because this phrase here, the roof covering or decking under the array shall be of non-combustible materials and shall include a 500 mm fire break between the arrays and any green roof if provided. And actually it's this first part of the sentence that makes it difficult for us, because the interpretation here is difficult. How do we interpret whether the roof covering or decking under the arrays should be of non-combustible materials? Does that mean that if we've got a concrete deck in place which is non-combustible, then you don't need to put anything else, you know, above between the solar PV system and the waterproofing? I would argue, yes, that is the case, but very often I'm about to show you a case study where that hasn't, this clause has not been interpreted like that. So the phrasing there does make it difficult for us, and I'm sure we'll come back to this in a moment, but we really, as an industry, we need to look at this and we need to work out exactly what we're trying to achieve and what this means, how this should be interpreted, because at the moment we as a designer get sent either this phrase or variations on it on almost every project in Ireland that we're working on, and it makes it difficult for us because it's not black and white there. We don't really know exactly what we should be designing to. And then the second part of that is the fire break between the arrays and the green roof, if provided. That's fine. I mean, ultimately, if the guidance is that we shouldn't be installing solar PV systems with green roofs, then that's how we design them. There isn't necessarily a problem there. However, the guidance, as we saw before, with you know, we are trying to move to we have a climate crisis, we have a biodiversity crisis. We should be looking to try and move to the best environmental solutions that we can. And I would like to make I feel like I could make a very good argument that doing a biosolar roof well is the most environmentally friendly solution you can provide on any kind of building roof. So hopefully we can have a conversation about that topic now as we open up for questions. The last 2 points on there, absolutely standard. So warning signage for firefighters, no problem at all, and solar cable suitable for outdoor applications, no problem at all as well. So yeah, quick case study. This is Edmund Rice College in Dublin, and what we've got here is a concrete deck. So the deck underneath that system is a concrete deck with a BTRS, so our Bauder total bituminous system, PIR insulation, ballast requirement underneath the solar array, and then we've got our gap between our PV area and our green roof system. Now this is actually our seed and blanket system, so that has B roof T4 including the vegetation, and this is the kind of project we're looking at now, and how this guidance is being interpreted. Couple of final points just before we get on to the questions. Warranties for solar, it's really important that we look at all the different warranties. There are, as I've shown, there's a number of different parts of a solar system. You have your mounting unit, you have your inverter, you have your panels. Very often, clients come to us looking specifically at the panel side, and that's the bit that always gets talked about. But actually, the inverter warranty is as important as the solar panels and the mounting system. The two areas of risk are panels coming off the roof and a fire, and your inverter and your mounting system are going to be your main areas of protection against that. And then finally, just design service. From a Bauder perspective, we will do a full design for you, for your clients, for the rest of your design teams, and we will give wind load calcs. We'll give a roof layout that shows how the system looks on the roof. Really easy to do. All we need from you or your design team is a target output, a CAD for new build, target output, CAD roof plan with a north point, building section and an address, and we can do the rest. In refurbishment, it's much more nuanced. We're looking at balancing it against the energy consumption, looking at return on investment. We will generally carry out a roof survey, and we'll do all of that at the front end. So I have managed to make that last 50 minutes. I hope that was of interest.